about the design of horizontal alignment, and in this topic the first topic is super elevation. So please write down the topic super elevation. So our main topic is design of horizontal alignment. So in this topic, the first topic is super elevation. So first of all, you have to know what is super elevation. In order to counteract the effect of the centrifugal force and to reduce the tendency of the vehicle to overturn or skid, the outer edge of the pavement is raised with respect to the inner edge of the pavement. So, suppose this is a pavement and this is inner edge and this is outer edge. So, to counteract the centrifugal force in the turning, the outer edge is raised with respect to the inner edge. So this amount of raise is known as actually super elevation. So by this definition we can write down that super elevation, please write down, to counteract the centrifugal force the outer edge of the pavement is raised to inner edge. This is known as super elevation. Okay, so this is the definition of super elevation. Now if we discuss it by a diagram, suppose this is the vehicle. Suppose this is the vehicle. Here are two wheels of the vehicle and this is actually CG of the vehicle and this is the centrifugal force that is known as P. And if the weight of the vehicle, if the pavement is in a turning portion, that means this is the outer edge and this is the inner edge, then this is actually W, that is the weight of the vehicle. So, and if this is the pavement of width, suppose this is the pavement and its width is denoted by capital B. So we can write down that by this weight of the vehicle and this is the centrifugal force, and suppose this angle is actually theta. So this angle should be theta. Then you can write down that there are different types of forces acting on super elevation. So please write down the forces acting on super elevation. Forces acting on super elevation. Okay, so first one is the centrifugal this is centrifugal force, which is denoted by P, and this value of P is actually W squared by GR, where W is the weight of the vehicle and V is the velocity of the vehicle, G is the gravitational acceleration, and R is the radius of horizontal card. So please write down W is weight of vehicle, V is the velocity, and G is the acceleration, and R is the radius of horizontal card. So this is centrifugal force, and the next force which is acting on the vehicle, that is the weight of the vehicle, that is denoted by W. So you can write down weight of vehicle, which is denoted by W. And the third thing is the frictional force. The third thing is frictional force. So this frictional force is between the vehicles, that means the wheels and pavement counteractions. Now this centrifugal force is opposed by the corresponding value of the friction developed and a component of the force of gravity due to the superelevation provided. So to analyze the superelevation phenomenon, you have to draw a figure. So please draw a figure of superelevation. Okay. So suppose this is the pavement and this is the vehicle actually, and it has two wheels. Now this is actually CG of the vehicle, and this is the amount of centrifugal force, which is denoted as P. Now again there is the weight of the vehicle, which is acting through the CG, is denoted by W. Now this pavement is actually lies in an angle of theta. So if we get the component of the centrifugal force and the weight of the vehicle, then we can easily write down that suppose this is actually the vertical axis and parallel axis of the pavement, then this angle should be theta and this angle should be theta. So by this component we can write down that this is a force of P, that is the component of the P, which is denoted by P cos theta, and this is the component which is a component of W, that is denoted by W cos theta. Similarly, we can write down that this component is also P sin theta, and this component is also W sin theta. Now there are also two forces, that is frictional forces, which is actually the vehicle is moving in this direction, so these frictional forces, that is FB, and these frictional forces should be FA if these points are A and B. And as the total load moves in this vertical direction, then there are two types of reaction force, that should be RA and RB. Okay, so this is the actual graphical representation of the figure. Now please draw the figure in your notebook, and after that we will analyze it. So in the analysis portion, you can write down for the first component, that is P cos theta, that is P cos theta, which is equal to W sin theta plus, there are two components, that is frictional force F of RA plus RB. So this is the equation which we get from the previous diagram. Now we can write down that in terms of RARB, we can write down that P cos theta equals to W sin theta plus RARB, means W cos theta and P sin theta. So this is W cos theta and P sin theta. So P cos theta, that is equals to, we can write down W sin theta plus F of W cos theta plus P sin theta. Now we will rearrange this equation, that is W sin theta plus FW cos theta plus FP sin theta, or we can write down cos theta minus F sin theta, and that is equals to W sin theta plus FW cos theta. So if we divide both sides by W cos theta, then what will be the value? The value should be P by W 1 minus F tan theta, and that is equals to tan theta plus small f, which is actually dividing both sides by W cos theta. So from this equation we can write down that P by W equals to E plus F. Why? Because here the F value is actually 0.15, and the value of tan theta, which is so small, so the multiplication of F into tan theta. So F into tan theta, that is too small amount which can be ignored. So we can write down that P by W equals to tan theta plus F, and this tan theta is actually denoted as small e, which is super elevation. So here we can write down that P by W, that is equals to E plus F. Again, from the basic equation, it is known to us that P by W equals to V square by GR. So please write down P by W, that is equals to E plus F, or we can write down V square by GR, that is equals to E plus F, or we can write down E plus F equals to V square by GR. So this is the actual equation of super elevation, where we can write down where E is the super elevation, F is the frictional coefficient, and V is the velocity, G is the acceleration, and R is the radius of curve. Okay, so this is the actual equation of equilibrium super elevation, where V is in meter per second. So this is important, where velocity is in meter per second. If we convert this into kilometer per hour, then the equation should be E plus F equals to V square by 127 R, where the value of V should be in kilometer per hour. Okay. Now we will discuss about the design of super elevation. So please write down steps for super elevation design. So what are the steps actually for super elevation design? The first one is the super elevation for 75% of design speed. That means to design the super elevation, the first thing we have to know that the design speed should be 75% of speed. This is the first step. So in this case, what will be the equation? And as well as the friction is neglected, and friction is neglected. So from the previous discussion, what is the equation? Equation was E plus F equals to V square by 127 R. Now this portion is 0 and V means 0.75 into V. So if we put this, then we will get like in this way, and this value should be V square by 225 R. Okay, so this value is V square by 225 R. And for the step 2, that is equals to the if the calculated speed or if the calculated super elevation is actually less than 0.07, that means 7%. So if E less than 7%, then this E is actually provided for the pavement. And if this value exceeds the 7%, that means 0.07, then we can provide the maximum super elevation, that is 0.07, and for that case we have to follow the step number 3. That means if E greater than 7%, then we have to calculate the coefficient of friction. Then we have to calculate the coefficient of friction, that is denoted as capital F, and this is actually V square by GR minus 0.07. And if this value of capital F exceeds 0.15, then the super elevation of design cannot be completed. Then you have to follow step number 4. But if this value, that is F less than 0.15, then you can say that the value of E from step 2 is so obtained. And if we have to follow the step number 4, then what will happen? Then the speed should be restricted. So for this case, speed should be restricted. And for this case, what will be the value of the speed restriction? That is V of restricted speed equals to 27.94 into R. This is the speed restricted in kilometer per hour. So these are the steps for super elevation design. Okay. Now please do a problem. Please write down a problem. That is, design the rate of super elevation for a horizontal car in a highway of radius 500 meter and speed 100 kilometer per hour. So, what are the given data? The given data are radius is 500 meter and speed is 100 kilometer per hour. So, you have to calculate. Now, for the first step, what is the value? That is E equals to V square by 225 R. Then we have to put this value like in this way, and if we calculate by calculator, then the value should be 0.08, which is greater than 7% actually. So we have to go check for the next step, that is coefficient of friction, that is V square by 127 R minus 0.07. And if we put this value in this equation, then you will get by the calculator the value is actually 0.08. The value is 0.08, which is less than 0.15. So we can write down that provide the value of superelevation, that is 0.07. Okay. Now this is the actual problem of superelevation design. Okay. So this is all about today's class. In my next video, I will discuss about the design of horizontal curves. Thank you.